Never, who would imagine, the game they lost.
So the first exam will be next Friday, which is the 17th. During our class, so 10 to 10:50. And you'll get on the link just like you did today, only you'll have your camera on so that I can see you. If your camera is not working on your computer, then come on through your phone and just have your phone sitting there so that I can see you, and then you can use your computer for everything else. But I have to be able to see you so that I'm watching what you're doing. The biggest thing is making sure you're not talking to anyone you cannot use your cell phone until the end to take a picture and attach it. I think that's everything. Any questions on that? So next week, most of the attendance will be you rewriting the rules for the test. You'll write it out and attach it, which means it's due Thursday. So I know you knew before the exam, which is Friday. So attendance next week will be due on Thursday. That's the only time that will happen is on exam weeks. Any questions? I'll put up an outline this weekend and we'll go over it next week. I don't think it'll take more than a day to go over it. So we'll probably talk about some of chapter 7. The beginning of the week and then review. So maybe Monday we'll talk about chapter 7 and then Tuesday and Wednesday will be the review. So I don't even think it'll take a day, but any questions? Chapter 2 is long and there's a lot of important details in it, so it's taking a little longer than most of the chapters will. Which is fine. I'd rather take my time. This one here, problem number 4, we had stopped on problem 3 last. Well, not last class. If you were not here last class, we talked about the disaster that just happened with the train derailment. And now there's articles that are coming up with acid rain and how that will affect us because these chemicals are acidic and so that can cause problems. But I'm sure in another couple weeks there'll be a lot more material to look at.
We were all bummed out.
On the exam, there's one similar to number 4. That's only highlighted because that's where I ended. But it is also, I think it's a good one to have on the exam. Is everyone able to use Desmos on their computer while they are on WebEx? Or I mean Zoom. Like on an exam, would you be able to open Desmos? And you'd be able to tell right now, if you go on Desmos, you should still be able to keep your camera on for me to see you. Because like for this one, you could use Desmos if you wanted. I'm going to show you both ways, solving it algebra and solving it graphing. But I think anytime you can use technology, it's a good thing. This isn't an algebra class where you have to be able to do it all by hand. Okay, so if we look at 4, Suppose a person has a retirement investment portfolio that consistently earns 4.5. Wait a minute, did I share my screen? It doesn't look like I did. All right, where's my Zoom? Sorry about that. It's recording, but I don't think I shared. Okay, so the exam, you have that though, but here I highlighted this one only because that's where I knew we stopped. But there is one like this on the exam. And there'll be a similar one on the review. So we'll go over more. Suppose a person has a retirement investment portfolio that consistently earns 4.5% annually. In retirement, she intends to draw $36,000 a year from this account. Calculate the non-zero equilibrium value of the investment portfolio. So there's a couple ways we can do this. When we have like a simple interest, the formula, and I'm sure you've seen, interest equals PRT. This is simple interest. Compounded interest is when you make interest off of the interest. So if I was getting the 4.5% in 1 year, any interest I made from that, the next year I'd make 4.5% off of everything. The simple interest is when you're only making 4.5% off of the money you first started with. So each year you're making the same amount. And it would also be if you're putting in the same amount as you're taking out, that's simple. Okay. We know per year. Here, let me give you what they stand for. I is interest. P is principal. It's your starting amount. R is the rate as a decimal. And T is time in years. In this case, since it's each year that we're looking at, T will be 1. So I equals PR times 1, which then is just PR. Any questions so far? To do it using algebra, we would plug into this formula. We know our starting amount. Or wait, starting amount's what we're looking for. We know the interest we want to make each year is the 36,000. We want to know how much needs to be in the account if we're making 4.5%. But when you're plugging in here, R has to be a decimal. So we need to rewrite 4.5%. So type into the chat, what is the decimal for 4.5%? I want to see everyone. I don't see anybody. When you have a percent and you want to make it a decimal, two ways you can do that. What's one way?
Divided by 100.
Come on. What? Yes, thank you. I will give you 2 extra credit points for being the only person that answered. So I will add that onto your test. Next week. Or you know what, I'm gonna put an extra credit column. That way it'll be easier. So in grade book, there'll be an extra credit column and I'll just keep adding to it. So this written as a decimal, and he could have gotten it, you're welcome, 2 different ways. One, you could take this and divide by 100, or 100 has 2 zeros. So you're taking away 2 place values because you're dividing by it. So you move it to the left 2 or divide by 100. Either way, you'll get the same thing. Any questions on that part? Now, if we want to, the reason we're setting the interest here is because that's how much they're going to take out each time. So we need to know how much needs to be in the account so that we're not losing money. We want to keep it equal. The amount going in matches the amount going out. That's your equilibrium. Now this is being multiplied. When you're solving an equation, to get rid of something, do the opposite. What's the opposite of multiplication? Anyone? Yes, divide. This way I don't have to write them. Okay. I'll give you guys extra credit. We divide. Because this is multiplication, you always do the opposite, which means divide. So if we divide 36 divided by 0.045, we get, we're getting 800,000. Three, 6, 1, 2, 3. Oh, okay. So if they are going to retire, what does this value tell us? If they are going to retire, or she, the person needs $800,000 in an account paying 4.5%. Then they can take out 36,000 every year and this money will stay there. Now, if you can't get that in there, then maybe you need a higher interest rate, or you need to realize that it's going to keep going down. So it wouldn't be in an equilibrium, or you take less out. Any questions on that? Now, to do it graphically, I'll show you that next. Okay. Go ahead and open Desmos. Now to graph it on Desmos, for the test, I want you to be able to do it both ways. But the formula you can write on a formula sheet. To graph on Desmos, we need two equations. We are always taking 36,000 out. So we know that y equals 36,000. It's a constant. Always going to be. The other one, I'm using y here because Desmos uses a y, not an I. But it's just this equation, which would be this, but then again, we only want x and y. So we're going to use, keep forgetting that zero. So this is principal. And this is interest. Because we only want to take out the interest. That way we keep the principal in there the whole time. So I'm just changing my variables. Principal times rate as a decimal times time. Yes. And we're talking about each year. So our time is a 1. Any questions so far? So I just switched my variables so I could use the graph, that's all. Desmos. I'm going to plug these two equations in. You just type it, y equals 36,000, and then hit enter and it'll go to the next one. Y equals 0.045x. Now notice you can't see the graph. Well, you can see one of them. You can zoom in or out. Now notice when I zoom in, it's going to get even closer. Can't see anything. Well, then let's do the other one. You can also play with the units, but since we don't know what they're going to be, and then you just hit it quickly. We know that 36,000 means these have to get high. Oh, now we're starting to see both lines. Oops, I went too far now. Now where they intersect, notice the 36,000, 800,000. The other thing, notice the purple line is a constant, it's horizontal. This one, this 0.045, that's your slope. So it's going up. The black line is slowly increasing, but it's increasing. And where they intersect is your equilibrium. So anytime you need to find an equilibrium, if you create the two equations, you can graph them. Oh, I didn't notice the PRT. PRT, well, some already answered it, but P is your principal, R is the rate as a decimal, and T is time in years. Now, on a test, when you need to attach your graph, just take a picture of this. So when you do it, now make sure you have the point marked like I have. To do that, when you click it the first time, if you move, it'll go away. It won't stay there. It'll show up, but then as soon as I move this, it goes away. To keep it, you click it one more time. But just take a picture so that I can see. Whoops, let's get rid of it again. so that I can see this and your equations. Any questions on that? So both ways we're getting the same answer. Any questions? There's some more definitions, and it's good to know the wording, but I'm not going to test you on these because it's a math class, not a science class. But it's good to know the terminology. That way, when we're talking about it, you know what it means. Conduction, when we're talking about heating and cool and insulation, conduction occurs when heat energy passes through a material. A closed thermos of hot coffee will cool by conduction as heat passes from the coffee through the container. Yes, we can. Okay, we'll do that first. Let's see, if we have right now, I think my mom has one, 2.1%. .1% per year, and we need, say we want to take out, I don't know, 25,000 per year. How much needs to be in the account so that if we're making 2.1% interest, we can take 25,000 out per year? So we want to withdraw 25,000. So what's happening is our interest is what's going into the account. And then we're taking a withdraw. For what's going in and what's going out to be in equilibrium, we want to keep the account balanced at our principal. So you could think of it as a graph. And we know this is 2.1%. So when you're asked to do a table or the graphs on the test, I just want to know that you understand how to the process. It does not have to be exactly like the book draws it. It could be as simple as this. I didn't notice one question. So the 800,000 is what they make for their retirement. The 800,000 is what they want to have in the account before they retire. So in order to just leave this sitting in the account and not use it, but take out 36,000 a year, this is what needs to be in the account before you retire or when you retire. It doesn't mean that they're going to give you that. Most retirements do not give you a lump sum, but maybe with what you'll be making on your retirement, you need this much more to stay where you're at. And so to do that, you'd need 800,000. So it's the amount you need when you retire, not necessarily what you're going to get for retirement. one case where you might get a lump sum. I know my father worked for Packard, which works with Lordstown. And when they closed, they could get a buyout. Or they could take the retirement. Since he had retirement for the military, he took the buyout and got a lump sum that he could put into an account. And then earn interest off of it. And so that's a case, but most of the time when you do just retire, you make like a monthly salary. There are not very many that have a pension plan where you get a lump sum. They're there, but not as many. So that would be your principal though, the amount you want to have in your account. If we do it by algebra, I know I'm already putting my Y in there. We can use this formula. We know we want to take 25,000 out each time. So our interest needs to be 25,000 so that this is at an equilibrium. 25,000 going in, 25,000 going out. That means my interest needs to be 25,000. I'm looking for how much money I need to have in this account. My rate is 2.1%. Written as a decimal. And then my time, if you want to put it in this formula, we took it out in the first one, but the time is 1 because it was per year. (2.1%) as a decimal. Divide that by 100. Did anyone find the answer yet? That would be the decimal, 0.021. What is P?
I have a question.
1, 2, 3. Yeah. Well, 19 cents, but now this 19 cents is important. If the 19 is not there, or if you don't round this up, each time it's going to be a little less. So if we look at this and leave it the 6. So we just dropped the change off. Notice if we take this and plug it in, will we make 25,000 in the first year? No, it's going to round to 25,000, but the bank is probably going to keep all of these decimal places. And so each year it's going down a little, but after 10 years, you could be actually having less money in your account. So when you're rounding, which is fine, in these cases, you should always round up. Because if we drop that off each year, that 19 cents is the account's gonna be going down. I mean, there's a lot in the account. Over $1 million that you would need in the account. But it's going to be going down just a little And if you only need it for 20 years, it probably isn't gonna affect anything. But it is going down. So rounding, we should actually round up. Any questions on that? Because that 19 cents is needed to stay at an equilibrium. Any questions? Okay, try it algebraically. Our constant is the 25,000. And our rate 0.021x. So we change that to 25,000. And if I can get right in the middle. Yeah, there it is. Now I know that I'm at the right spot because of the 25,000. There's 1,190,476.19. Any questions on that? I'll create another one that we'll practice next week, but is there any questions on that? Yes. I think I'm going to have you use both. That way I know you understand the technology, but also that you're able to do the algebra, because this is just a basic one. Is everyone able to stay on Zoom and get onto Desmos? It's not like sometimes computers run slower. If you are having trouble, let me know. And then maybe what I'll do is I'll have a take-home portion where you graph it and an in-class portion where you work it out with algebra. No. So this amount, which we're going to round up, if we can find an interest rate at 2.1%, then this is how much needs to be in the account to make 25,000. So you're making 25,000 every year. This is just sitting in the account. So it is each year. Each year, if you have this in an account, you will make this. a flow chart you could think of, if this is the account. So this is the money we have in the account. Now they use this money. This is our P. We get 2.1% of this. So if you take 0.021 times your P, you're gonna get approximately 25,000. So that's the interest going into the account. You're only making 25,000. And then you're going to remove 25,000. So we wanted to find what P value would need to be in this account so that I'd be putting in the same amount that I'm taking out. So this is an account that you're just letting sit, and it's only making interest. And whatever the interest is that's going in, that's what you want to take out. Correct. They already have, well, hopefully they have this. This is what they need. So if I was thinking about retiring in 20 years, if I could find an account at 2.1% and I wanted to withdraw this amount, then this is what I would need to have in that account. It's one way of checking on like how much you need. And let's see, if you think of the lottery and they say you could take one lump sum, or you could take so much each month or year. This is what they're looking at to see how much you would take out. So they're putting that lump sum in an account and you're just getting the interest off of it. And that's also why then you could get more. But if you take it all at once, then you don't get as much. That helps. Any questions on that? Positive. I think it's an important one because you can think about it. Now, if you go look at account like banks and try and find interest rates, so they're really low right now. There was one time when like I had enough money when I was younger to pay my car off, but my savings account made more interest than I was paying on the interest in my car. So I was better off leaving it in my savings account because I was making more than I would be saving. Because say my account was bringing in $50. But the interest on my car, maybe it was only $25. So rather than paying my car off, because I'm bringing 50 in and only taking 25 out, this keeps adding 50 more. It's not in an equilibrium and I'm not pulling more out than I'm adding. So it was better off not paying my car off. And that's different things you want to look at. If the interest rate is really high on something, so then maybe your own 50s going in, but then if you have a credit card, it could be 25% interest. So maybe 120 is going out in interest. You want to pay that off then because you don't have enough going in to balance what's coming out. And so here you're trying to find a balance so you don't have to touch your savings when you retire. Any questions on that? But this same process can be used now when you think about how much you're paying on a credit card or a car. But credit cards will say free for 60 days. But then if you have one payment late, you go from a 5% credit card to a 25% in 1 month. So be careful of that. But any questions on that? Positive. Heating and insulation. Conduction occurs when heat energy passes through a material. Closed thermos of hot coffee will cool by conduction as heat passes through the coffee in the container to the cooler area. So what happens is conduction is when the one part's hot and it's spreading to the colder area. So you have a hot and a cold. We talked a little bit about that with NASA and making energy. It was conduction because the hot air went to the cooler. And they keep building more and more stronger insulation cups. A home can also lose heat by convection. This occurs when heat energy is carried on currents of air or another fluid. It could be water. Some people, if you have water heaters, the child leaves the door open on a winter day and a parent exclaims, "You're letting the heat out." The parent is complaining about heat lost by convection. One simple model does not take into account convection losses. Because you think about the house, you have the windows, the walls, if they're not insulated good. The one side of our house, the wall's a lot colder because the garage is on the other side. It doesn't have the brick that the rest of the house has. And so all of those are convections being lost. Finally, a warm object emits heat by radiation. At an intensity, figure 23 shows a thermographic image. I think it was page 99. Thought I had it written. Oh yeah, figure 23, page 99. Where did I put the book? Here. So you could do, when you're buying a house, you always have somebody come and check everything first. And when they do that, they should also be able to do a thermal imaging so that you can see where heat is being lost. So it's showing where the heat loss or where insulation is missing. So these walls are not insulated well. But that is radiation. And it depends on the surface temperature. Any questions on that? So there's 3 different kinds of heating and cooling. One way we can model home heating is like this. And that's what this problem asks you to do. A home is heated by a furnace that is controlled by a thermostat. Heat is lost through the structure of the house by conduction. The rate at which heat is lost depends on the temperature difference between the outside and the inside. And that's important to know when we do our ratings, which you'll see in a minute. Regarding the amount of heat in the home as stock. So the stock is your heat because when you turn a thermostat on, it heats up the air and then it goes out. When it cools, it's a loss. So in this case, you're talking about the heat in the air is your stock. So it comes in through the thermostat and goes to heat the home, and then it goes out. It can go out through the walls, through the windows, through the floor. But this is one possible stock model. They put little faucets here because you can control the temperature. You can turn it on and off. You can have air conditioning. You can do the same way when it's hot outside. Now, we don't have as much control of this, but we could shut all our doors. We could insulate. So there's ways of making this stronger. And that's why they have the spigot there. The blue arrows are the flow, how it's flowing. These red ones are how it's taking things away, like heat loss. Heat can go back through the thermostat and come back in and heat the home, the air, or it can escape through the open door, the window, and that's why this is going both ways. So this is a continuous cycle, but we do lose some air to the outside. Any questions on that? Now, the one thing I had mentioned we're missing, because we need to know the temperature on the inside and the outside, is a number called an R value. It's the insulation quality. Now, when you buy insulation for your home, it has a rating. And what that rating is it's how well it's going to keep your hot air in and your cold air out, or vice versa in the summer. But each one has an R rating. The higher the R value, the better insulation. So the R value of building component is the measure of the thermal resistance, how effectively the component impedes the passage of heat, how well it keeps it in or out, depending on the time of year. The higher the R value, the better the insulation, and therefore less energy your home is going to need. Now, they use this delta or triangle means change in T. It's how the temperature is changing. And that is just your outside temperature, and subtract your outside and your inside temperature. In this one, we're assuming that the inside is the hot temperature. But it's just your temperature inside minus your temperature outside. That's what this is. Then the area of your wall, length times width, and then this is your R value. So it's this whole formula tells you the rate of heat loss. Usually, if you're using US measurements, it's hours, degrees Fahrenheit, feet squared per BTUs. Which, I mean, you need that kind of for the variables, but not so much for the other part. Let's look at a problem. Oh, it's 10 till. I guess we'll do a problem next class. But there will be an R value on the test. It'll be a nice basic one like this one. There's also one I want to show you. I think I might, I don't know. It's a lot more complicated. But any questions?